In today's lesson, we are going to see an introduction to the use of namespaces and the creation of libraries. In case that you don't have the project that we have done so far, just download it from this link. And in this lesson, we are going to keep organizing our project to make it grow in a more stable way. What we are going to do is that we are going to create 3 libraries that we will be able to use in other projects. We will create the library utils, that will be a collection of general utilities to manage the basic parts of our project. The library networking, utilities related to the management of network communications, and the library VR, utilities related with VR management. Before creating the libraries, we are going to make an exercise that will help us in order to make the network library totally independent from the project. After that, we are going to include the support of Mirror SDK to handle the network communications. And since we are going to prepare the option to choose between different multiplayer SDKs, we need to abstract our functionality. So what we are going to do is we are going to create a network controller that will be the interface with the rest of the system in order to make the game work in network independently from what network SDK we are using for the network communications. So we are going to abstract the network functionality. What you are going to do is, first of all, duplicate the script network controller and rename the new one with the name photon controller. On the photon controller script, you will do these actions. First of all, remove the void dispatch event and its definition. What will happen is that when the event on photon event is being called, you will call the interface with the rest of the system. That will be the network controller, and you will use the dispatch event from there. Back to the script network controller, you are going to make it so it inherits from a scriptable object. Take as a reference what we did with the system event controller. And you are going to remove most of the methods, and you are going to leave the method dispatch event and its definition. You are going to refactor the photon network event with the new name of multiplayer network event. You are going to define getters and setters that will make reference to the new photon controller Singleton. Next, in the method connect, you are now going to call the photon controller instance connect. And when we need to dispatch an event through the network with the method dispatch network event, now we will call the photon controller instance and use their dispatch network event to dispatch the event through the photon network. On the prefab network controller, just rename it and make sure that it has the script photon controller. So with these instructions in mind, do all the steps to create both network controller and photon controller. So in other stages of this lesson, we would be able to replace the photon controller by the mirror controller. Okay, so go ahead and do it. And the result should look similar to this. What we have first done, just we have copied the network controller class, and we have renamed it as photon controller. Okay. In here, aside from changing the network controller name for the photon controller name, we have make this change. Instead of using the local dispatch event, we are using the one of the network controller, because now the network controller is going to work as a middleware. It's going to stand in the way of the rest of the system and the libraries related with the communications, because our goal is to be able to choose between Photon, Mirror, or any network library that we can choose. And on the network controller, we have converted the network controller to a scriptable object, because it consumes less memory, and for dispatching even it was a really good solution. And as I said, this works as a middleware between the rest of the system and the network libraries. And we have renamed the Photon network event by multiplayer network event in order to abstract the functionality of the dispatched network events. And we have converted this to a scriptable object. Now for the getters, we are just asking to the Photon controller the information. For the connect, we are also asking the Photon to connect. And finally, when we need to dispatch a network event, we are just calling the Photon controller dispatch network event. If everything works right and we proceed to copy the changes to the copies, we can proceed to run, and we should get exactly the same behavior as before. Okay, so let's connect the first client. Let's wait for the other. Let's connect the second client. And both clients are connected and they are working. Okay. The next step in the process of abstracting the functionality of the network, so the rest of the system doesn't need to know which network libraries is using, is to create a preprocessor constant, enable Photon, that will encapsulate all the code related to Photon. The idea is that we can encapsulate all the Photon logic, so we can enable or disable at will. And what we are going to do in order to test that this has worked right, we are going to do another copy of the project. And this copy, we will remove the libraries from the assets folder. And we will test with the preprocessor constant enable Photon and without it. Okay? When we work with the preprocessor constant, then it will complain. But if the preprocessor constant is not there, then it shouldn't complain. That way we should know that we did it right. Okay, so go ahead and do it. and the result should look similar to this. What we have done is just to encapsulate anything related with Photon inside the enable Photon preprocessor constant. Okay, we have started first with the network controller, then we did the Photon controller. We are encapsulating this section, and since we are interested to that this file can be found by the system, because if it's not found, then it can give some problems, we are just encapsulating this section, and in the case that the preprocessor constant is not there, this is going to inherit from mono behavior. And what we have done next was about the instantiation. We have abstracted the instantiation, so the system doesn't need to know that it is using Photon in order to do it. And I have created the methods on network controller and then on the Photon controller. Okay, and the Photon controller do the final instantiation. And for the avatar class, what we have done is to encapsulate the component Photon view, okay, and all the instances where Photon view was appearing, we have encapsulated them with the preprocessor constant. And to check that everything was properly encapsulated, what we have done is just to copy with the batch file all the changes, and we created a new client, okay, a new copy of the project. And in this project there is not the Photon network library, okay, and this project is not using the enable Photon preprocessor constant. So what happens with this project is that well, it will work in single player, there are no compiler errors, it will work, it should work as a single player game without issues, okay, so it's working in single player, but in multiplayer it's not going to work because the library is no longer there, okay. Finally, we just did the test of multiplayer, okay, just to make sure that everything was working properly. So we played the two multiplayer clients with the Photon library just to make sure that everything was working properly. So that in the two projects we enable the preprocessor constant enable Photon, okay, and everything should be working as expected, okay. So now I am going to propose you an exercise, and first the question: could we apply any of the solid principles to the avatar class to be more specific in the access to the network? Okay, so far we are accessing through the component Photon view at the level of avatar. So could we apply any of the solid principles to make the code cleaner and more scalable? Just think about it. Okay, and so far I have identified two principles that we could use in order to improve our system. The first principle would be the least code substitution principle, because functions that use pointers or reference to base class must be able to use object of derived classes without knowing it, okay. So this principle states that okay, we need access to the network, but we don't need to know which internal SDK library we are using for the network communications. We don't need to know, so we can replace at any time that functionality, that network library, by another one that will be the case when we use mirror, without breaking the system. And the other principle that we can apply is the dependency inversion principle, because our code should work upon abstractions and not concretions, because right now for this particular case, we are using a concretion that is the photon view component. So we need to abstract this one into a new element. And what you are going to do right now is create that element. To create a component pattern called network game ID that will be added to all the game objects that have photon components in order to be that interface for the network components. Okay, so what will happen is you will add this component pattern to all the game objects who have photon view and photon transform, and the system will communicate through the network game ID with these two elements, making it transparent for the rest of the system the way which network SDK is using. Okay, so go ahead and do it. So the code should look similar to this. What we have first done, we have created the new component, network game ID, and this network game ID is a component pattern that will work as an interface for the game objects who needs network communications to communicate without the need of knowing which network SDK is using the system. Okay, so what will happen is that avatar will have check if there is this component pattern, this network game ID, and this network game ID will manage if the communications are going to be performed with Photon, with Mirror, or with any other network SDK. For this network game ID, we have implemented all the necessary functions, for example, the getViewID, where we got the unique identification for the network object, if the object is mine, if I am the owner. So we have implemented all the methods that we were using spread around multiple places on the code. Now we have centralized all of this through this component. Okay, after that it was only a matter of using its get view, its is mine, and all the methods that we have defined here. Okay, so now in all the places that are using these methods, we don't need to use the preprocessor constant enable photon anymore, because all the logic of Photon has been encapsulated just right here. Okay, so we have created an interface that all the game objects with network components will use to communicate with the final components. Okay, then what we have done is for all the game objects that are using Photon view and photon transform, as you can see, we have selected all of them. They are using photon view and photon transform, and here there is the network game ID. Okay, so right now the system, instead of using directly the photon view and photon transform, is going to use the component network game ID. Okay, if everything works fine, we should be able first of all to test if the multiplayer works. Copy the changes and run both clients. Okay, so it seems that it is working. And also check for the project where we deleted the Photon network library, because we were interested to know that without the Photon network library the project was working fine. Okay, so in this project that we don't have the Photon network library and we are not using the preprocessor constant enable Photon, we also need to check if also this project is working. So if we play single player, we should be able to perform and run the game without major issues. Okay. So in your site, just check that it is working. In the case that you got lost during the process, just download the code of the project right here and continue from there. So now that we have done some pre-production work in order to abstract the network functionality, it's time for the creation of the libraries. The goal of creating a library is that other future projects could take advantage of the work that we have done here. But before creating the network library, we are going to create the library utils that will contain the most basic common elements that haven't any dependency with other code. So we are going to create this folder structure where we will organize our game and libraries. So move all the scripts to the folder asset game. I am going to do it with you. So let's go to the project, and in here what we are going to do is we are going to create two folders. One folder that will be game and another folder that would be libraries. Okay, and now we can move all these three inside the folder game. Now inside the folder libraries, we are going to create two folders, the folder utils and the folder networking. So we are going to start with the library utils. And the exercise that we are going to do is we are going to find out what scripts we could place in that folder, in the folder utils. These scripts shouldn't have any dependency from any other code at all. I am going to help you out in order to move the first scripts to the utils folder, and the two scripts that we are going to move to that utils folder will be the system event controller and also the sounds controller. So let's go to the project, and then in the utils folder we are going to create a folder controllers just to replicate exactly the same structure that we have here. Okay, so we have controllers and we have events. Okay, so what we are interested to do is just right now we are going to move this script to this folder, because what we want is that every time we import these libraries in any other project, we can take advantage of this system event controller. Okay, so let's go to edit the file. So what do we have here? We have the name of the events that are being used in our project that are specific from the game. And that's a problem because the folder utils shouldn't have any dependency with the game. Okay, so we are going to do necessary changes just to only have in the utils folder functionality that is totally independent from the game. Okay, to do that, what we are going to do is this. We are going to create a new script, system event game controller, and this new script is going to inherit from the system event controller. Okay, so we are going to inherit from the system event controller. Okay, and now for the system event controller, we are going to move all the connections with the game that are the name of the events. we are going to move them from the system event controller to the system event game controller. Okay, so this right here. So now system event controller doesn't have any dependency with any other part of the game project. We can import this in any other Unity project and it will work fine. Okay, so but what we need to do now is, okay, now we have plenty of compiler errors, because in all the places that we were using the events, we were making reference to that. So to fix that, right now we are going to just replace, okay? We are going to replace system event controller dot event by system event game controller dot event, and we are going to replace all of this in the entire solution. We press replace, all the instances that were using that have been replaced. If we proceed to save and check in the Unity project, we shouldn't have any compilation error. Okay, so now we have disconnected what is the system event controller, the functionality that we can use in other projects, from the specific events. Okay, just to make sure that everything is still working, just press play and check that everything is working. Okay, so everything seems to be working. Good. Now let's do the same for the sounds controller. Okay, so what we are going to do is, okay, we are going to create a new folder for the sounds right here, and we are going to move the sounds controller from the game to the folder sounds. If we proceed to edit the file, we have these constants that make reference to the game. So we are going to do the same that we did for the system event controller for the sounds controller. Okay, so we create a new script called sounds game controller. This one is going to inherit from sounds controller, and we are going to move all the reference to the game to that new script. Now, for all the reference that are using that code in the game, we need to change them. Okay, so what we are going to do is just to replace in all the places with the new name. Save it. Just make sure that nothing is broken, so there are no compiler errors. Good. But here we need to do some more changes, because this the sounds controller because for the sounds controller we attach it to the prefab sounds controller, and now we need to use our sounds game controller. So you are going to remove from that prefab the sounds controller, okay, and you are going now to add the new sounds game controller, okay, and just add the sounds that you are using. Okay, And now we are good to go. If we proceed, first of all, just to restore the sound, because we disable it in order not to get in the way. So you can enable it here. And if we press play, we'll get the sound. Okay, this is right. And everything seems to be working fine. Good. Let's disable the sound so it's not in the way. And now, in your own, you are going to try to find out what other scripts you could move to that utils folder. Okay? There is at least one script that it's really straightforward to move from one place to another, and you won't need to change anything. So go ahead and do it. So the functionality that I have been able to move from the game to the library in order for future projects to take advantage of all the work that we have done here, the result has been like this. We have gone through all the elements that we have identified in our project, and for all the elements that we can encapsulate its behavior and disconnect them from anything game related, we have moved it there. We have moved it to the library. For example, for the input, the input is something that is going to be similar for all the projects, and we have moved that from the game folder to just the library because it is something that we can use in any other projects. It has no connection, no specific connection with anything game related. And for the events that were defined in the system event game controller, events that were connecting this specific code, the input controller, with the game, we have moved that events from the system event game controller to the input controller, just in this case, okay? Because this event input controller enable mobile HUD, it's something that it doesn't have a connection with the game. It's something that it's exclusive from the input controller module. And the only thing that we have had to do is for all the instances that we're using the event, instead of referencing the system event game controller, we are referencing right now the input controller. Okay, because the game controller, of course, can make reference to the library, but the library cannot make reference to the code, to the game. Okay, and the input controller doesn't know who is using it. The input controller now, it's just a module that offers the functionality of getting the input, but it doesn't know about who is using that functionality, and that the game controller just make reference to the functionality won't break the fact that we have converted the input controller just to an independent module. Other scripts that we have moved to the library has been the ones that were on the utils folder. These ones were already disconnected from anything, so we only had to move from this folder to the library folder. Okay. Other screens that we have moved to the library folder, for example, one of the most basic ones, that is the language controller. And when you import your collection of libraries, you would be able to use your language controller module with other projects. We have also moved the camera controller. We have detected that we can abstract it and disconnect it from what is the game. Okay, the camera controller is also an element like the input controller. It's something that it's going to be similar, at least for first person and third person games. And what we have done here is we had this reference to this interface, okay, iPlayer. But iPlayer offered plenty of functionality that we didn't need it for this particular case, okay. We only needed less functionality. That's why we have created the new interface in order to apply one of the solid principles, that is the interface segregation principle, that specifies that many client-specific interfaces are better than one general purpose interface. So what we have done here is just to create a new interface that is really small. It only defines only this, that is what is strictly necessary for the camera controller to work. Okay, and this new interface we have placed it inside the library and the camera folder, and we have used this interface in our interface ePlayer, so it inherits from that interface. Okay, so back into the camera controller. Now this interface is inside the library. Okay, it doesn't have any connection with the library, so we have broken the connection with the game. That was the connection with the game, and now we don't have the connection with the game because we are working with an interface that is implemented in the same library, so there is no connection with the game. And of course, in the game, we have had to make reference to that the player was going to implement that interface. But right now, for the camera controller, we have applied one of the solid principles in order to just abstract the functionality. Another script that we have also moved to the library folder has been the screen controller. The screen controller is a controller that you are going to use in multiple projects. You are going to need just a script that handles the creation and destruction of your screens. So it was also a good candidate to move it to the library folder. And we have made some changes that happened right here. Right here, we had a connection with the game, in specific with the camera, with the game camera. So what we are doing here, remember that our middleware, our system event controller, was going to help us to communicate with other parts of the system without knowing what other parts of the system were there. And we have created this new event that it will just run necessary steps in order to perform the operation that was performed before. So all these scripts that we have been able to move from the game to the library folder meet also the solid principle of open-close principle. Okay, so software entities should be open for extension but closed for modification. So what will happen is that when you need just to change the behavior of an existing element of a library, the right step would be just to create a new class that extends from any of the modules you need to extend, and there you will specify logic related to your specific game project. Okay, we have done it for example, in the system event controller. We were extending the system event controller just to specify the name of the events that the game was going to use. So this is one of the applications of the open-close principle. We did the same for the sounds controller, and we can do the same for the camera controller, the screen controller. Any controller should be ready for extension, but we have just to try not to modify it. Okay, because eventually you would have this collection of libraries, and this collection of libraries is going to be shared by multiple projects. So you have to be extremely careful when modifying something in the library. That's why the solid principles of open-close principle is so important to take into consideration that these classes that are on the library should be closed for modification. So now that we have done plenty of work, we are going to use the namespaces in order to complete our libraries. Okay? So, for all the scripts that you have included in your library, you are going to type the namespace like this. I am going to show you, and you are going to do it in your site. So let's start, for example, with the utilities. And here you are going to specify, I am going to specify, for example, my own name, the name of my project. Okay. And you can specify a kind of extension. You can make the extension as as large as you want. Okay. And what would happen is that now that you are using the namespace, in order to use this specific script, you would need to import this specific name. You would have to make reference to this specific name when you are importing the necessary libraries in the header of the files. Okay, right now if we go to the Unity project, we will get plenty of errors. Okay, because now for all the places that the utilities script is being used, now we have to import the library. So for example, in this case, control dot, and as you can see, now you can import the library. So if we go to the header of this file, now we are using what is contained in the library utils. Okay, so go ahead and do first of all, just add the namespace for all the entries, for all the scripts that are on the library folder, for all the scripts that are on the utils folder, and then in the game you would need to make reference every time you to make reference to something of the library. You would need to import to use that specific library, that specific namespace. So go ahead and do it. So the result should look similar to this. For all the scripts that are on the library utils, we have added the namespace for all of them. And in all the places that we were using all these files, we are just importing that same namespace. Okay. Another thing that we have done I have detected that there was a behavior that it was strictly related with the game, that it was the commander mode. So what I have done is that for the mobile input manager, we just removed anything related with the specific game, and I have left only the necessary code that is not connected with the game. That is just the move joystick, the rotation joystick, and the detection of the action, jump, and camera change button. Okay, as I told before, we try to meet the solid principle, open close principle. So we have just removed anything connected with the game, and what we have done is to extend this mobile input manager, and in this extension we are implementing the logic about the commander mode. Finally, what we have done in the prefab, we have replaced the mobile input manager by the mobile input game manager. Another good practice is that you also add the namespace to your game files, because this is another good way to see if a module has a dependency with the game project. So go ahead, and for the files that are on the game folder, what you are going to do is just to add a namespace. Okay, so you are going to add namespace, and for example, just name it as game, and do it for all the files on your game project. Go ahead and do it. So now it's the time to repeat the whole process, but for the creation of the networking library. Okay, so what you are going to do is take all the code of the network, create a new folder in the library, place it there. You are going to name the namespace with your own custom name, and you are going to fix anything that could be broken. So go ahead and do it. In order to check that we have created an independent library with the utils library, we can test it by creating an empty project and putting there the utils library. If there are no dependencies with the game, with the files that are on the utils library, there shouldn't be any compilation errors. So let's do it. Let's create an empty project. Okay, so here in the assets folder, just paste the utils, go to the project, and if there are no compilation errors, is that we did our job right. Okay, let's check the console. Okay, so we didn't got any compilation errors. Okay, the next test that we need to do is just to copy the folder networking and do the same. Go to this folder, to the empty project, paste it there, and again we shouldn't get any compilation errors. Okay, so we have created two independent libraries, the utils library that is totally independent from anything else, and the networking library that has dependencies on the utils library, but neither of them have any dependency with the game application. In the case that you got stuck in any of the steps that we have done, you can download the code of the project from this link and continue from there. After working integrating the Mirror SDK in order to use it for the network communications, I have realized that it is too complex at this stage in order for you to do it. So what I am going to do is to show you the changes I have done in order for to be able to choose between Photon or Mirror for the network communications. You can download the full code of the project already finished from this link. So what has been done is to have a new preprocessor constant that allows the activation of the Mirror SDK. Okay, if we go to the preprocessor constants, we see that now we have defined this preprocessor constant enable mirror in order to choose the Mirror SDK for network communications. What happens in the code for the network communications is that right now we are considering Photon and Mirror. For Mirror, what we have done is, as we did with Photon, we created a controller. In this case, it's called Mirror Controller. And what it does, this Mirror Controller, is something similar that Photon Controller was doing. Okay, you can see disable this code because we are not in Photon configuration, we are on Mirror configuration, so the code of Photon is disabled, and what Mirror does is just exactly the same but using the Mirror SDK. Also, since anything related to Mirror SDK or Photon SDK is contained in the library networking, in the project, we don't need to know about what network SDK we are using. It's totally transparent for the game what network SDK we are using. So let's check the folder structure that we have done. And there are two folders, the Mirror folder and the Photon folder. In the Photon folder we placed the Photon controller, and on the Mirror folder we placed the Mirror controller and the Mirror connection. Okay, as I said, the Mirror controller will be our main access point to manage all the Mirror functionality as we did with Photon controller, and the Mirror connection keeps the information about the application's connection. The approach to network communications of Mirror and Photon is quite different, and we need some more elements in order to be able to control it with Mirror. Now let's go back to Unity editor and let's examine what we have done with the prefabs. Okay, and for all the elements that are going to be networked, we have added two component patterns. The component network identity, that it works in exactly the same way as the photon view. It provides an identity inside the network, and the network transform, that also works similar to photon transform view. It will handle the synchronization of the transform across the network for that particular unit. And we have added for all the instances that were going to be networked these elements. Okay. The next thing that we have done is that we need to instantiate the mirror controller, and you can find the mirror controller inside the resources, prefabs, network, mirror. The code will instantiate the mirror controller in order for the mirror controller that we have created to be on the scene in runtime. The most important part that I can highlight right now would be that this section right here are the references to all the network prefabs that we can instantiate during the runtime. Okay, as you can see, all are references to all the avatars that need to be instantiated in the network. Another thing that is extremely important is the player object mirror connection. Okay, this will keep information about the current connection. So now we can proceed to test the mirror communications, and we are going to just ensure that the base project, the preprocessor constant enable mirror, is there. And for the copy client desktop, we have to also make sure that the preprocessor constant enable mirror is also there. Okay, if both Unity editor instances have the preprocessor constant enabled mirror in their configuration, then we can proceed to run the application. We start and we land in the game. So right now the server has started. There are a couple of messages that will help you out to differentiate from Photon. Now let's go with the other client, multiplayer, and we have the other client. Everything seems to be working fine. Just to make sure that we didn't break anything related with Photon, what we can do is just to change the preprocessor constant from enable mirror to enable Photon in both Unity instances. Okay, apply the changes, go to the other Unity instance, also change to Photon, and apply the changes. Once the preprocessor constant has been applied, we can proceed to run the game, but now we will be running in Photon. Okay, so now we are running on Photon configuration, and we are just going to check that the game still works for Photon. Okay, so the game is running as expected. Finally, I have also extracted all related VR functionality from the game to the VR library. And I have integrated the support for more VR platforms, for more VR hardware, like Pico Neo or HTC Vive. Okay, you can download the SDKs from the links. And back to the Unity editor, we can check what we have done. Okay, so here is the VR folder, and for example, the VR input is a script that inherits from input controller, and this script is just extending the functionality of input controller. Remember the solid principle of open closed, and what we are doing here is just we are extending the functionality of the input controller. So we have removed anything related to VR from the input controller, and we are now using inheritance just to manage anything related with VR. And as you can see here, you can use now 3 different preprocessor constants: enable Oculus, enable Pico Neo, and enable HTC Vive. What will happen here is that depending the platform that you are going to use, the sections of the code that relate to that platform will be enabled. Okay, the idea is that the game is transparent to the way the information is presented to the user. It can be desktop, it can be VR, it can be different VR platforms. The game shouldn't care about the way the information is being presented to the player. To conclude this part of the lesson, what I can highlight is that now on the clients folder, you have, for the different VR platforms, different projects. Okay, you have what we did for Oculus Quest right here, but now you also have the project for Pico Neo with the libraries of Pico Neo, and the HTC Vive project with the libraries of HTC. Okay, and the batch file that allows us to copy the changes from root project to the copies has been updated, so all the changes are copied in all these copies. In the last part of this lesson, we are going to be introduced to the JIT modules. That is something that will help you out to create tools that you can reuse in multiple projects. So we have created our libraries that are independent from the game. And now we can go to our control version code tool, that is JIT, and we can create libraries that we will be using for multiple of our projects. And the repositories that we are going to create are going to be three repositories: the repository of utils, the repository of networking, and the repository of VR. In each of these 3 repositories, we will put all the code that we have created for our libraries. So now we are going to create the repository for our full Unity project, but we will remove the libraries before making the first commit. Okay? So we are going to create a new repository. So go to the GitHub and create a repository for the full project. Optional description. For the moment, I will set that private. Later on, I will change to public, so you can also have access. I will add a README, and I will create this repository right now. Okay. So the next thing that I am going to do is just to clone this empty repository. So we are going to copy the link, clone it, and we are going to choose one path. Once chosen one destination path, we can proceed to clone it. Okay, now go to the previous path, and right here we are going to copy all the project in there. Now back to the source tree, and you are going to ignore everything inside clients. Okay, so add it to the ignore. So add it to the ignore files. Everything inside clients must be out. Also must be out for the moment, what we are going to do is that for the libraries, we are going to just cut them, move them out. We are going to create maybe a folder here and libraries. Okay. We have moved all the libraries to an empty folder. Okay, so now we are not interested to commit them within the full project. And we should also ignore the commit of the Photon library, because Photon is a paid library, and so we should be good to go. We have ignored everything inside clients. We have moved all the files of the library to just an empty folder, and we have ignored the Photon library. So this should be our initial commit. Stage all. It will complain about files above 10 megabytes, but we can proceed without major issues. Once everything has committed and pushed, let's check in the GitHub if everything has been uploaded. Okay, we have our assets folder. We don't have the Photon folder. We don't have here the clients folder. That's right. And in the games folder, there is no library folder yet. Okay. So what we are going to do now, we are going to create a new repository. Okay. So create a new repository, and we are going to create the 3 repositories that I have just mentioned. Okay. The first one would be the utils. So another one would be the networking. And the final one would be the VR. Now we are going to proceed to add these repositories as submodules of our full project. So what you're going to do is right mouse click, select add submodule, and you are going to choose the previously created repositories. Okay, so go to the repositories, and let's start with the utilities repository. Copy the link, and now you can add it as a submodule, and now you can choose the folder and create a new folder, in this case utils, and in here select it. Okay, and these 2 files will appear, just initial commits also. And if you go to the project, now you have a Git file in the utils. Okay, so now you can proceed to go where we move our library files, and just copy paste and add it, in this case, to the utils. Okay, back to the source tree, in the submodules folder, in the assets, game, libraries, here there will be an entry utils. Double click with the mouse, and these are the files that are contained right here, that are the utility files that are totally independent from the game code. Okay, So now it's time to commit it. Stage all, commit and push. Okay. Now let's do the same for the other submodules. So go add a new submodule. Let's go to the GitHub. Let's select the networking, copy the link, go to the source tree, and now we are going to add the other library. Go to the game, libraries, and here create the folder networking, select it, okay, do the initial commit to finally confirm the new submodule. Now go back to your temporary folder, and for all the files of the networking library, we are going to move them to the GitHub, to this repository. Paste it, and now back to the source tree, we select the entry of the submodules networking, and here we have also all the files related with the networking. Okay, so we can proceed to stage all, commit them, and push. And the final module that we need to do is the VR module. Copy the link, go to the source tree, in the full project, add a new module, paste the path, select in the libraries, create a new folder, VR, press OK, do the initial commit of the submodule, and go to your file explorer, and the final library we have to move is the one related with VR. Okay, so back to the source tree. For VR, we have all the files that we have done for the VR. So we are going to stage all, and we're done. To summarize what we have done, first of all, we have created the full project, leaving out all the libraries, because what we want by creating the different repositories for each one of the libraries is that we can use these submodules in future projects. Okay, so after creating this first initial project, then we have proceeded to create and add each one of the libraries. Okay, now to confirm that everything is working fine, you can proceed to open the project, run it, check that the functionality is working. Okay, so it's working. So now what we have is that we have our repository where we have the full project, but the code related with the libraries has its own repository. Okay, and all the changes that you can make in these libraries are going to be committed in their respective repositories. Just let's make a small example. Just modify some file. For example, for the text entry, to keep the consistency of the project, since I haven't used comments, these comments are not needed. Okay, so what would happen is that these changes would be for the utils library. Okay, they won't be a part of the main project. Okay, as you can see, we have modified this file, but this file is not inside the full project. It's a part of the libraries. Okay, so you have to be especially careful when you modify files from the libraries, because when you have multiple projects and these multiple projects use shared libraries, a change in one of these libraries can have a really big impact on other projects. So you have to be extremely careful when dealing with submodules. That's why the solid principle about open closed, open for extension, closed for modification, fits with the goal of using submodules as an architectural method to create projects. Okay, just let's finish with this. So now you are ready to grow. You have your collection of libraries that you will keep improving so other projects can benefit from the progress done. You have to be especially careful because the libraries will eventually be shared by multiple projects. And the way it works in bigger projects is that you have programmers working on the core, meaning the libraries, while other programmers work on the front-end application. So in short, this is what it looks like to be a part of a professional software development project.